Welcome to page 8 of semester 2 exam review. Let's get going. Find the foci of the ellipse. The center of the ellipse is at 0, 0. If I was going to graph it, which I'm going to, I would go to 0, 0. I would go right and left square root of 28, a little more than 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, yep, and 6. 1, 2, 3, 4, 5. I would go up and down 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I would draw my ellipse. Let's try to draw my ellipse. Okay. I need to recognize this is tall. The foci are going to be in here and here. Foci, you can't spell foci without C. The biggest of these values, here's B. B is square root of 28, and A, the larger of these, is square root of 64, 8. So the foci are up here, and our rule is 64A squared equals B squared, 28 plus C squared, so C squared equals 64 minus 28. 64 minus 30 would be 34, so this is 36. Didn't quite subtract that much. Oh, that's pretty convenient. C is just 6, so our vertices are up 6, down 6. 0, 6, 0, negative 6. Be careful. Find the center of the ellipse. I'm going to group my x's. I'm going to factor out a 4. 4 times x squared minus 8x, leave a blank. I'm going to group my y's, factor out a 9. Plus 9 times y squared plus 2y equals, I'm going to subtract 37 to the other side. I'm going to complete the square. Half of 8, 4. 4 squared, 16. Half of 2, 1. 1 squared, 1. However, I did not add 16. I just added, if I distribute, I just added 64. I did not add 1. I just added 9. And I'm going to be particularly lazy on this one. We're going to go negative 37 plus 64 plus 9. And we get 18 equals 4 times x minus 4 squared plus 9 times y plus 1 squared equals this. And to get this in standard form for ellipse, I'd divide both sides by 18, but I just want the center. The center is my Vox 4, my Voy, negative 1, or C. Find the center of the hyperbola. I'm going to group the x's, factor out a 9. 9x squared plus 6x. I'm going to group the y's, factor out a negative 1. I'm even going to put it here. I get y squared, factor out a negative, this becomes minus 2y, and I'm going to subtract 71 to the other side. Half of 6, 3. 3 squared plus 9. But I just added 81. Plus 81, I'm going to run into my own work. Half of negative 2, negative 1. Negative 1 squared plus 1, but I just subtracted 1. And I get 9 times x plus 3 squared minus 1 times y minus 1 squared equals, let's see, that would be 9 minus 1, I'd get, or excuse me, 10 minus 1, I'd get 9. In the next step, I would divide by 9 to get in the standard form of a hyperbola, but I just want the center. My Vox, negative 3. My Voy, 1. Moving right along. Find the foci. Now we got some work to do. At least it's in standard form. So let's go ahead and sketch this. The center is my Vox 2, my Voy, negative 1. Center's right here. In an x direction, right, left, I'm going to go 4. out to here, 4 left, 1, 2, 3, 4, back to -2, -1. In a y direction, I'm going to go up and down 3, up 1, 2, 3, down 1, 2, 3. I'm going to build my little rectangle that we build for hyperbolas. I'm going to get my asymptotes in there. And this opens in a, this is positive x squared, negative y squared, so it opens in an x direction. It looks like this. And the foci then would be curved around somewhere here and here. The foci are the biggest value of a, b, and c. C's the biggest, so this is c squared equals a squared plus b squared, or c squared equals 16 plus 9, or c equals square root of 25, 5. So we should be to the right 5, left 5 from the center, so our foci, 5 to the right of there would be 7, -1. 5 to the left of 2 would be -3, -1. Or C. All right. What rectangular equation is given by these parametric equations? One really nice way to do this would be just to have this be t equals y plus 2. Substitute y plus 2 in for t, and I get x equals y plus 2 squared. That's eliminating the parameter. An option, maybe not as good as this, in this case would be I could graph this parametrically. I could go in my calculator and go to mode parametric and put this in for x and y, and then try to see, does it look like this? We know what that one looks like. Does it look like that? We know what that one looks like. We got a reasonable idea what those look like. But this is our graph right here. Let's see. Looks like it's going to be this one. Yep, if we FOIL this out, we clearly, I'd like to say, get C. All right, need another piece of scratch paper here. Now, what are the rectangular coordinates for this point right here? I'm going to rotate 3/4 pi, so 1/4, 2/4, 3/4. I'm really sitting, aiming this way, and I'm throwing a distance of 2. So here's a distance of 2 right there. If that's 2 to get back to this side on a 45, 45, I have to divide by √2. This is 2 on square root of 2. This is 2 on square root of 2, but it's negative. But 2 divided by square root of 2 is just square root of 2. So this is square root of 2. This one is negative square root of 2. So negative square root of 2 to the left, square root of 2, and up square root of 2. All right. What is the polar equation? Now, here's where we're going to be really slick with this. What's the polar equation of this parabola? Boy, it's been a while since we did some of this, so how about we just take advantage of our calculator here. I'm going to go into mode, where are we at here? Polar, and I'm going to, see, I know what this thing looks like. This looks like that. So let's see, mode polar. I'm going to go into window. I think I just need to go 0 to, I'm in radians. I think I just need to go 0 to 2 pi. And I don't want to take very big steps. I think 0.1 is just fine. And we'll try it with x min, x max. Let's go y equals. Let's clear this guy. And I'm going to just do 2 sine of theta and graph it. And that is most definitely not it. So I'm going to go back into, is not the parabola. And I'm going to go 0.5 sine, let's see, sine of theta, cosine, you can't put the squared there, so you got to go theta, close parentheses, and then square, and we graph that thing. And that is definitely not it. Now we got some challenges here because these next two are basically pretty much similar function. Let's go y equals clear. I get 2 tangent secant theta, 2 tangent theta, and then I would have to divide by cosine theta. And we'll graph that one. Okay, that looks pretty decent. That looks like our parabola. However, let's graph this second one. So I'm just going to go 0.5 or 1/2. I'll go 0.5. 0.5 tangent theta divided by, it doesn't matter which order we do it in, divided by cosine theta. And I graph that second one, and it's the taller one. And this, by the time I get over 1 unit, I should be up 2 steps here. And the red one looks like, if I go, let's try this, trace. If I trace over to around x equals 1 on that one, I'm only up at 0.59. But if I trace over close to 1 on the x graph, I'm up right at 2. So it is actually D. Now there are other ways to do that, but that's not a bad option for us on that problem. Alrighty. We're in polars. Let's go ahead and take advantage of this. I don't know. Let's see what it is. I'm going to clear that second one out, clear the first one out. I'm going to enter this as a fraction just because I can. So we get 5 on 3 minus 2 sine of theta. And I still like theta going 0 to 2 pi. I'm set that way right now. I'm negative 10 to 10. Let's see what we got. Okay, so certainly not a parabola. Might be a circle? Maybe. Might be an ellipse? Maybe. Certainly not a hyperbola. Now, you might be saying it looks a little more elliptical. What we want to do here is we want to go ahead and get square tick marks. In other words, I want the width of the tick marks. See how they're a little wider down here on the x-axis as they are on the y-axis? So I'm going to go ahead and go zoom square. What zoom square does is it makes those tick marks the same size. And now, wow, that became really, really clear. We've got an ellipse. Okay, so prior to that, it looked like maybe it was an ellipse, but it actually looked like a wide one. This is most definitely, because the tick marks are squared out, this is most definitely an ellipse. There's other ways to do that as well, but that's a pretty effective approach on a multiple choice question. Which is a way of expressing this point. Okay, let's see. I aim pi on 4, I throw 3 this way. Reflected across here. Well, that would be reflected right to there. Let's see, if I rotate negative pi on 4, aim this way and throw it backwards 3, we got it. A is good. Let's just talk about these other ones real quickly. What if I go backwards pi on 4 and throw 3, we'd be down here. If I go forwards 3/4 pi and throw it backwards, I'd be down here. And if I go forward 5/4 pi, 1, 2, 3, 4, 5/4 pi, and throw, I'd be down here. So it is just A. And that is page 8. And if you're just looking at page 8, on the day that I've done this, I won't have page 9 or 10 done, but those will most definitely be done by tomorrow.